All right, my name is Caitlin Goodwin.
I'm Kyle Gulshin.
Hi, I'm Connor Brady.
I'm Brigitte Reth.
I'm Jacob Harmon.
About 4 years ago, in 2009-2010 school year, I was hearing my technology colleagues talking about this robotics and how they were using it in their curriculum, and the kids were really excelling and learning a lot. And through further investigation, I found out that there's lots of competitions out there in robotics, but probably the premier program is FIRST Robotics.
Yeah, it's been kind of crazy. We've had kind of a Cinderella story. Our first 2 or 3 years, we actually made it to the international competition, which was kind of a surprise, but really awesome.
I got started into it because my brother was a senior on the initial team, and I was kind of his sidekick, following him around. Got a taste for it, came back the next year, really loved it, did a lot of really neat things in designing and then creating and then seeing the end product, and that really interested me. So
I got interested in the robotics and mainly computers when I was really young. So I've always dabbled around in computer science and programming and stuff. And you know, did some robotics camps and stuff when I was little, really loved math. I'm just a real computer geek. So then when I got to high school and there was talk going around about starting a robotics team, you know, I had to just jump into that. I had to see what it was all about. So now I'm lead programmer on the team. What we do is we set up circuitry to test and program, and we'll compile code and we'll test code, and we put the brains in the robot.
I think I would be considered the lead fabrication guy out on the floor, actually building it, putting it together. I mean, I assist everyone else in the design process immensely on the computer, but I'm also the one who gets his hands dirty and actually builds and constructs what we design.
My first year, I did a little of everything, including some CAD, working with the digital version of the robot.
I was the president of the team last year, the COO, or Chief Operations Officer, and I'm a programmer, and I've been a team member all 3 years.
I'm Dennis Harmon. I retired in 2005. My son had a great interest in robotics programming. He came here and he was a member for the first year of the team. The second year, they were looking for mentors. I am absolutely blown away by their skill, by their talent, these kids, and their desire to learn.
The first year we had 2 students that just took the programming and just ran with it. And then the last 2 years we've been very fortunate. 2 of our students have been able to pick up C++ and they've been running with it, and now they're teaching the new students this year.
This is a typical programming workstation. This is what we would be doing every day for the 6 weeks that we work on the robot. We have a test board, which is just a collection of circuitry that would kind of resemble what's on the actual robot. This isn't the full extent of the circuitry. Obviously we can't fit it all here, but we've got typical things to play with. We've got a motor controls and some motors screwed on the sides, and we've got window motors here, which are just more powerful motors. This is the C-Rio. It's kind of like the brains of the robot. It's what does the actual computational logic that we program on it. Connection lights, we typically have a modem on here, but right now we're just wired into a laptop that we'd be deploying code on. We'd be working on our code and we'd be deploying it onto the robot and testing it and back and forth. Digital sidecars that are connected to, we've got several different types of sensors, potentiometers, toggle switches, limit switches. We would typically have a camera wired on over here. We would have all kinds of different inputs that we could be playing with while we're working on sample testing, like line sensors and line trackers and photo cells. And then we just take all of this and we open a programming environment, and we open our IDE, and we go through thousands and thousands of lines of code that control this robot, everything from the beginning of the match when it has to run on its own and autonomous, to the teleop control, which we just control with joysticks when we're actually competing. All controlled with 2 joysticks. We have 2 different models just because we needed a 3-axis joystick, one that can go around in all different directions. We needed joysticks with more buttons with throttles. And then when it's all done, we compile the code, we deploy it to the C-Rio, or we would deploy it to the robot C-Rio. We would wire this into modems, and so we can get wireless communication on the field, and then we send the robot out to competition.
One of the things that first really inspires in kids is gracious professionalism, and then also we use a term called cooperation. So our robotics competitions are not like a heated battle like you go to a football game. Everything is positive, teams root for other teams, and it doesn't get heated, and it's all about helping each other to be better.
It's such an amazing atmosphere that everyone's friends with everyone else. You cheer for every single team, whether it's yours, someone else's. Even if you're competing against them, you will cheer for them when they score a goal.
I think teams really pull in a lot of different people, so you don't have to be like, you know, the most gung-ho math guy that there ever was. You know, there's a lot of different positions, but you do meet those people too, obviously, because programming can be pretty intensive sometimes with math and science and those kind of things. So I think it's just really nice to meet these people at competitions. You know, you're meeting people who are kind of like you from around the world when you get to international competition. And you know, first kind of carries over to colleges a little bit. There's first scholarships and things like that, and you know, people will know, oh, you're from a FIRST program, so that's an immediate connection. And some of the things you do, just you know, the general problem solving that FIRST entails, trying to get a robot to work with all the different things that could go wrong, I think that really prepares you more than anything for college and career beyond.
Take what they've learned here, and if they go into any type of like programming in a manufacturing environment where they're programming different types of machines, just about everything they've learned here would be, you know, they could apply to something like that.
The competition that we're in is very exciting. It'll keep you on edge when you watch these kids compete. But every one of these kids can go pro. Every one of them can walk out of this with skills that will make them a very, very good living in life. Not many athletes that go to high school can say that. I think it's like 1 in 250,000.
I'd say, you know, take those classes that maybe you don't want to take because you know they'll be difficult, but take them anyways because they will help you out in the long run.
From the outside, a stranger seeing, oh my gosh, a robotics team, well, I don't know how to build a robot, oh my gosh, I wouldn't even know where to start. Well, it's not near as intimidating as it is whenever you tackle it as a team together. And we have lots of generous mentors here to help us through the parts that we don't know. And really, I can say that when I came on my first year, I did not know anything about building robots, but now, after having all the help from my mentors and my other teammates, I can safely say that I know my way around the shop and I know how to construct something that can do a task proper.